Assalamualaikum and good morning everyone, especially to you sir. So my topic is all about integral of transcendental function. So when you say transcendental function, those function that contains logarithm, natural logarithm, and exponential its function. So this is the integration rule for integrating transcendental function. Let's solve the problem. Okay, we have the integration of 5e raised to 4y dy. Now, in this case, we know that the rule that could be applicable in this type of function is the integration of eu du is equal to e raised to u plus c. Now, in this case, since we have the constant 5, then we can move 5 outside of the integration that we can rewrite the equation as 5 integration of e raised to 4y dy. However, before we can apply this rule, we need to identify first to which is u in this case. Now, we know that our u in that case is equal to 4y. Since this is our u here from our general form e raised to u, now our du if we derive for y, that would give us 4 dy. However, since we only have dy in the integrand, then we introduce multiplier that is 4. Our equation has changed upon putting a multiplier in the function. So in that case, we need to come up a multiplier outside of the integration that is reciprocal to the number 4. That means we need to multiply 1/4 outside of the equation. Why? It's because since if we multiply 1/4 and 4, that would give us 1. That would lead us the conclusion that our equation has not changed because as if that we are multiplying 1 in the equation, that any number multiplied by 1, that is still the number itself. So in this case, since we have already satisfied this rule, that is e raised to u, this one now is our du. This rule has been satisfied by our functions. So in that case, we can now finally use this form, and that would give us, since we have 1/4 outside of the integration, then we have also 5, then that can be written as 5/4 e raised to 4y plus c. So now this is our final answer. Now, let's proceed to the trigonometric function. We have here the formula. So now, this is the problem number 1. Cos x minus 1 minus sine squared x. So, we can rewrite it into integration of cosine x dx minus integration of sine squared x cosine x dx into integration of u squared du is equal to u squared over 3 plus c. Now, our u is equal to sine x and du is equal to cosine x dx. Now, sine x minus sine x cubed, which is the value of u, over 3. So, the integration of cosine raised to 5 x sine x dx, that our u is equal to cosine x negative 1 times du is equal to negative sine x dx is equal to negative du is equal to sine x dx. Now we're going to substitute the integration of cosine raised to 5x sine x dx into du all over negative sine is equal to dx. So the integration u raised to 5 sine x du all over negative sine x is equal to integration of u raised to 5 du is equal to negative u raised to 6 over 6 plus c. Now, the final answer is negative 1 over 6 cosine raised to 6 of x plus c. Now let's proceed to the number 2. We have u is equal to x cubed. So du all over 3 is equal to 3x squared dx all over 3. Now we're canceling the 3. So we can rewrite it into 1 over 3 du is equal to x squared dx. So the integration of x squared csc squared x cubed dx is equal to integration of csc squared x cubed of x squared dx is equal to integration of csc squared u times 1 over 3 du. Now let's copy the 1 over 3 integration of csc squared u du is equal to 1 over 3 minus cot u plus c. So the final answer is negative 1/3 cot. What is the value of our u, which is the x cubed plus c, which is constant. So let's proceed to the number 3. So we have u is equal to square root of x, that is equal to x raised to 1/2. Now du is equal to 1/2 x raised to 1/2 dx multiplying by 2, that is equal to 2 du is equal to dx over x raised to 1/2. So integration of secant square root of x dx all over square root of x is equal to integration of sec u times 2 du. So that is equal to 2 ln secant u plus tan u plus c. That is the formula. So the final answer is 2 ln secant what is the value of our u, which is square root of x plus tan square root of x plus c, which is constant. Now let's proceed to the inverse trigonometric function. Here is the formula. Now this is the number 1. Integral of dx all over x squared plus 9. So we can rewrite the integral as the integral of dx all over x squared plus 3 squared. Okay, so this in turns, our u is equal to x and a is 3. Alright, our value of a is 3, not the 9, because according to the formula, this line is in terms of squared. So we have to have the integral of this denominator resembles the integral that would fill an arctan because of the a squared plus u squared. Our formula would be 1 over a, which is 3. Then we have arctan of u over a. The value of u is x. Okay, the x all over a, which is 3 plus c. So this is the final answer. So now let's proceed to the problem number 2. We have the integral of dx all over square root of 25 minus 16x squared. So we can rewrite this first as integral of dx all over square root of 5 squared. It is equivalent to 25 minus we have the 4x squared. So the value of our a here, which is the constant, is 5. The value of our u here is 4x. So now what are we going to do is we simply get the derivative, so we will be using u substitution here. Because as we can see, we have a u of value of 4x, get the derivative of u with respect to x. That is 4 dx. Then we're going to get the dx, that would be du all over 4, so that we can substitute here the dx. So what will happen is that we have the integral of du all over 4, that is dx. We use u substitution all over, we have the square root of d, that is a squared, that is the value of our a, 5 minus we have the u squared, which is u is equal to 4x. So we can factor out 1/4 outside of the integral sign. We have du all over square root of a squared minus u squared, which is actually an integral yielding arc sign. So we have 1/4 multiplied by the integral of this, and that the integral of that would be arc sign of u all over a plus c. Okay, so this is equivalent to 1/4 distribute the 1/4 times arc sign would be arc sign u all over a plus 1/4 times constant is still plus c. But remember, our u is equal to 4x and our a is equal to 5. So we have to back substitute that. So we have 1/4 arc sign of u, which is 4x all over 5 plus c. So this is our final answer. So let's move on to the problem number 3. Integral of dx all over x square root of x 4 root minus 1. So how will we get the integral of that? So we write at integral of dx all over x square root of x squared minus 1. The x squared would be our u and the 1 is our a. So use substitution again. So we have u is equal to x squared. We have du is equal to 2x dx. So we have du all over 2 equal x dx. Now the problem here is I don't have x dx. So I would simply multiply this whole equation dx all over x square root of x squared minus 1 squared. X over x, alright. So multiply it by x over x is still valid as long as you can multiply it in the numerator in the denominator because x over x is still equal to 1. So simply this would become x the integral of x dx all over x squared over the square root. Okay, multiplied by the square root of the x squared minus x squared. So we're going to substitute it, so x dx will now be equal to du all over 2 all over we have x squared here and x squared is equal to u. The square root of u squared minus a squared. So we can factor out 1/2 outside of the integral sign so that we have du all over u multiplied by u squared minus a squared, of which this arc secant are right. So we have now 1/2 multiplied by 1 over a arc secant of u over a plus c. That would be 1/2 1 over a over okay is still 1 over 1 arc secant still 1. Arc secant of u, which is our u, is x squared and our a is 1 plus c. So our final answer would be 1/2 arc secant x squared plus c. So now let's proceed to the exponential and logarithmic function. Here is the formula. So now let's proceed to the examples of exponential function. Evaluate the integration of e raised to negative 3x dx. So here is the solution. To solve that, integration of e raised to 3x dx is equal to integration of eu times negative 1 over 3 du. So our value of u here is equal to negative 3x and the du over negative 3x is equal to negative 3 dx all over negative 3. So we're going to cancel it. And then that is equal to 1 over 3 du is equal to dx. So our formula here is integration of eu du. Now, negative 1 over 3 integration of eu du is equal to negative 1 over 3 e raised to negative 3x plus c. That is our final answer. Now let's proceed to the example number 2. Evaluate the integration of 10 raised to negative 2x dx. So to solve that, the value of our u here is equal to negative 2x. So, du over negative 2 equal negative 2x all over negative 2. So, we're going to cancel it, and that is equal to 1/2 du is equal to dx. Now, the integration of 10 raised to negative 2x dx is equal to negative 1/2 integration of e raised to u du, our formula, and that is equal to negative 1 over 2 times 10 raised to 2x all over natural logarithm of 10 plus c. So that is equal to negative 10 raised to 2x over 2 natural logarithm of 10 plus c. That is our final answer. So this is a number 3 example. We have integration of e raised to 4x dx. Now the value of our u is equal to 4x, then du all over 4 is equal to 4 dx all over 4. So we're going to cancel it, and that is equal to 1/4 du is equal to dx. Now, the integration of e raised to 4x dx is equal to integration of e raised to u times the value of our x, which is 1/4 du is equal to 1/4 integration of eu du. So, our formula, and that is equal to 1/4 e raised to 4x plus c. That is our final answer. Now, let's proceed to the examples of logarithmic functions. Number 1. Evaluate the integral of x dx all over x squared minus 4. So, here is the solution. Our u is equal to x squared minus 4, and our du is equal to 2x dx. To integrate the x dx all over x squared minus 4 is equal to 1/2 ln u, or x squared negative 4 plus c. So this is the problem number 2. Evaluate the integral of x squared plus 2 all over x cubed plus 6x plus 7 dx. So here is the solution. Our u is equal to x cubed plus 6x plus 7, and our du is equal to 3x squared plus 6 dx. That is equal to 3x squared plus 2 dx. To integrate the x squared plus 2 all over x cubed plus 6x plus 7 dx, that is equal to 1 over 3 integral of 3x squared plus 2d all over x cubed plus 6x plus 7, which is the value of our du all over u. Therefore, we have 1 over 3 ln of x cubed plus 6x plus 7, which is the value of our u, plus c, which is constant. So, this is the last examples of logarithmic function. Evaluate the integral of x plus 1 all over x minus 1 dx. So, here is the solution. X plus 1 all over x minus 1 is an improper fraction. So, we divide the numerator by the denominator and obtain x plus 1 all over x minus 1 is equal to 1 plus 2 all over x minus 1. Therefore, to integrate the x plus 1 all over x minus 1 dx is equal to integral of 1 plus 2 all over x minus 1 dx. That is equal to integral of dx plus 2 integral of 1 all over x minus 1 dx. So, the final answer is x plus 2 ln of x minus 1, which is our u, plus c. So that's all.